How's it going, guys? Today we're going to be working on Leetcode question 1647. It is medium difficulty. It's called minimum deletions to make character frequencies unique. Okay, so in this question we're given a string S, and we're trying to figure out if it's good. And if it's not good, how many characters do we remove it so that it is good? So what is good? A good string is when the frequencies of all the characters that exist in the string are not the same. Okay, so say we had this string, we had A, B, 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 and C, C. We see that there are 3 A's, 3 B's, and 2 C's. Okay, those numbers are called frequencies. Frequencies is how many of the same of one character exists in there. So the frequency of A is 3 because there are 3 A's in there. We also see that frequency of A and B are the same, which means this is not a good string, and the question is, how many letters do we remove so that it is a good string? There's a couple ways to do this for the string. Okay, we can see here, you can see the explanation here, that if we remove 2 B's, that means we're going to have 3 A's, 1 B, and 2 C's, and none of those frequencies are the same. Or we can remove 1 B or 1 C, making there to be 3 A's, 2 B's, and 1 C, and no clashing frequencies. And each of those takes the number. Each of those take two deletions. Of course, we could do removing 3 A's, which leads us to 3 B's and 2 C's, and 0 A's. But in that case, we're removing 3 letters, so that doesn't really work. Okay. So for sure, the first thing we'll need to do about this question. So I'm gonna try this. I'm gonna write this example here. Okay, so we have triple A, triple B, double C. Okay, so I have this. The goal here is to essentially make all the frequencies unique, right? But we for sure need to keep track of how many frequencies there are for each character. So we could use a dictionary. Today we're going to be using a thing called collections.counter. Okay, it works the same way as a dictionary, but it just takes in the string S and it'll make the dictionary for us. So just so we understand what's going on here, we have A, right? B has 3, C has 2. So all this is saying, okay, this is just some data type that tells us there's 3 A's, 3 B's, and 2 C's. And the goal here is to make each of these numbers unique. Sorry, all of these numbers to be unique, right? In this case, we have 2 3's and 1 2, so that's not good. Okay. So let's just write this to be clear. Let's just say we had, we're storing these numbers to be like this. Okay, we need these to be unique. Now our question seems a little bit, we can look at the question differently. Okay, so how do we make these unique? Well, we can go through each of these numbers, and then because the goal here is to decrement any of these numbers so that they're all unique, and making sure that it's minimum. So the key here is to think of it as each number has a place to fill. Okay, so say we had a set. Okay, so we had a set. Okay, we know that there can never be. Let's make this darker. There can never be 2 numbers that are the same. Okay, and in this case we can use a set. Okay, so say we filled in, they can never be the same. So say we just filled in. So our first loop we filled in. So let's just call this S. Okay, our set S. So first we filled in. Our set has. Our set has the number 3. Okay. So 3 doesn't exist in the set yet. Okay, the goal of this set is to keep track of what frequencies we used. So if we go on the first number, okay, we see that 3 doesn't exist in the set yet, so we're going to add 3. Okay, and then the second loop, we're going to go to the next number 3. We see that 3 does exist in here. What that really means is, hey, we already have a letter that has the frequency 3. So you're going to need to decrement that until it's not in the set anymore, right? Since A already took the count of 3, B has to take a different count that is not 3 and less than 3. So we're going to decrement it by 1, right? B becomes 2, and then we see that 2 is not in the set S, so now we can add it. Okay, so now B has taken the place of frequency 2, A has taken the place of frequency 3, and then we're going to go to C, right? C has a frequency of 2. 2 is already in the set, so let's decrement it by 1. 1 is not in the set, therefore we have 3, 2, 1. And every single time that we decrement a number, this frequency count, all we're saying is that's how many characters we'll be removing from the string, right? In this case, when we decremented this 3 to 2, all we're saying is we're going to remove 1b. When we're decrementing this 2 to 1, all we're saying is we're removing 1c. Okay, and we're going to add those two together, right? So add those two numbers together. In this case, is 2, right? This is our count, really. But this is how many we're going to be removing, right? I hope that makes a bit of sense. And one thing we'll think about also is what if it goes down to 0? So say if we had 3, 2, 1, and then we had, let's say, letter Z that had a count of 3, right? We had a letter Z that had a count of 3. Well, in this case, using the same algorithm that we just said, let's say, so it's 3 exists in here, decremented by 1, count becomes 3 now. Now 2 is already in here, decrement that, count becomes 4, decrement that, count becomes 5, and decrement that again, now we have Z is equal to 0. And that's perfectly fine. If Z is 0, that means what happened was we're saying Z couldn't be 3 because A took that spot, Z couldn't be 2 because B took that spot, and the same thing goes for C. Z couldn't take 1 because C has that spot, therefore it had to be 0. And in this case, we'll be removing 5 letters instead. Okay. In this case, we're always going to be taking the minimum amount of deletions because we're filling in every single, you can think of it as a frequency spot, a frequency slot that we can put in. So let's just start coding it out now. How do we do this? So instead of making an actual dictionary doing this, you can do this too. There's a very useful built-in data type called collections.counter. It does exactly the same thing, and it takes in the counter s. Okay, so each key is going to be a character, and each value is going to be how many times that character occurs in string s. Okay, and then we're going to have a result equals 0. So this is what we're going to increment every single time we take out a letter during our loop. And then we're just going to call our set as to be set. Okay. Sorry, our set to be, we don't want to be calling it, so just say used. Okay, so this is going to have all of the integers, which represent really letters, that has taken up that spot in the set. So remember, A goes in here, so if there's a 3 here, that means a letter has taken up the spot 3. A letter B has taken the spot 2, and it's like I explained before. So we're gonna loop through. We're gonna loop through our dictionary, so-called, and we just use .items for that. Okay, so this is gonna be a character. It's gonna be a frequency. Okay, and while we're looping through, if the frequency is ever 0. That means there's at least one letter in there that we haven't decremented all the way to 0. So we haven't removed all the letters yet, and it's still in used, right? So remember, if it's in here, and it's at least greater than 0, that means that letter is still in the string. If that letter is still in the string and it's in here, that means we need to keep decrementing it, because we cannot have, this means we have the same frequency as another letter, and this means it still exists in the string. Okay, and what we're gonna do here is, again, we're gonna decrement the number until we find a spot. Okay, and we're also going to add our result by 1. Okay, and every single time that we're done this, okay, so frequency is at some number, all we're gonna do is add frequency. Okay, that's where we're gonna add it. We already have our count, and we're gonna be decrementing all the way until either 0 or until the letter finds a spot, or the number finds a spot, and then we're gonna return res. Okay, so we'll run the code. Submit, and we have a really good answer. This answer is that I found it in discussions. It's obviously not mine. My solution is very ugly, but it was very useful to be able to understand this and explain it to you guys. So thanks for watching. Hope to see you in the next